So I think we can kick off. And hey, good morning, everybody. Welcome. And today's topic will be about data lakes and analytical services. So I think everybody knows me, but my name is Ursula. I'm from Amazon Web Services. I will be doing this session alone today. We have a lot of people now having the autumn flu. So I may not see the questions as you put them in the chat. So let's at the end take like a Q&A session. And if there's any issues, so Sanna, if you see that I would have like the presentation doesn't show something like really critical, please just stop me and then we'll fix it if something happens. So the topic is data lakes and analytical services. We got a lot of feedback about the accounts last time. And yes, you will get accounts also after this session. So you will have 72 hours of account access. And I have something really cool for you that you can build. So there is an exercise that is actually a full-scale data lake exercise. And it's something that if you, for example, want to build your CV portfolio, you can do so. So you're allowed to do so and share that also together with your CV that, hey, this is something I built. Like, of course, taking like screenshots and things is allowed. So that's nice to do. And because it's a full-scale build, even though it has, of course, example data for you, it's something that is kind of comprehensive to share also when you're applying for roles. So I think everybody knows me. So my name is Ursula. I'm currently based in Finland. I work for Amazon Web Services. And I'm also the EMEA Amazon lead, so the LGBTQ+ lead for Amazon and Amazon Web Services. The whole series that we are doing is also sponsored by Amazon. So I want to send out a thank you for our global team. So the funding is very much appreciated. So before we kick off today, I just want to remind you of what we are doing and how this belongs to the series. So what we are talking about. And so kind of the key questions is that why are we here? What are we doing? Who are we? So we are talking about data engineering. So this is part of the data engineering track. And this is data engineering tracks in context of you can actually aim for certification or you just can aim for learning. So you basically can take bits and pieces here and there and learn those. You don't have to take part in the whole series if you don't need it. If you want to take part in the whole series, you're welcome to do so. I looked at the data and thank you for answering the questions about the start level. So we seem to have from beginners to also quite advanced. So we have a lot of people in the audience that also have some experience. Some have more than others. So depending on your start level, you can decide which parts will actually serve you the best. And of course, based on what are you looking at? Are you looking at, for example, switching roles, getting your new first role? So where are you going? Or are you just wanting to educate yourself to learn something new? So there are different goals, of course, for each individual. And also always happy to take feedback if there's something that we may have overlooked at some point. So if you look at the certification actually belongs to a series, so the Data Engineer Associate. And Data Engineer Associate can be taken separately. So if you want to take just the Data Engineer Associate to show that you have the capabilities of a data engineer, you're fully welcome to do so. Some combine it with different things. So some do the cloud practitioner first, and then they might do even solution architect. You don't have to. So it's just a suggestion that some people combine it with different things. And I don't know if you have noticed that, but when you look at like LinkedIn and any social media, you see that there are people who are doing all and every Amazon Web Services certification out there to earn a golden jacket. So when you have all the certifications, you get a golden jacket. And that is making people really competitive. So that is kind of also a funny exercise to do, but that's a lot of work. But we are focusing on the data engineering associate. It is associate level, so meaning that you have practitioner, which is a fundamental level, you have associate, which is the middle level, and then you have professional. So you can do any of those levels, but of course the professional is always the hardest level to gain. So those are the hardest levels. And looking at the statistics globally, it looks like that professional on Amazon Web Services level seems to be the hardest certificate to earn compared to any certifications currently. What does the certification include? So it has 4 domains. So there's domains of how do you pull in data and how do you transform it? How do you do data store management? So basically the layer that holds the data. How do you do data operations and support? And how do you do data security and governance? Today's topic will actually touch upon each and every topic a bit, but we are talking a lot about the data store management. We will talk a lot about the security and governance. And then we will be, of course, naturally talking about the ingest and transformation, just a small piece of operations and support. And like mentioned, not everybody's journey is same. So if you're looking at the journey of somebody else, so it won't be necessarily always from A to B. So let's get going and let's start with the topic at hand for today. So which is the data lakes and analytical services. And I would like to start by talking about and comparing a bit, because last time we talked about the purpose-built data services. And let's start by talking about what is a data lake, what are the benefits, why would you use a data lake? And then I will share certain things that how I see data lakes. And remember, my background is in relational databases, basically all kinds of databases, but relational databases, security, compliance, governance side. So I may take a different view. So I will take a view from the project experience that I have. My project experience is actually in 3 main industries. So I have done a lot of financial industries. So meaning banks, stock market, all kinds of financial institutions. I've done a lot of hospital and governmental services. So basically healthcare, and also governmental controlled services. And then I have a funny addition to that, because if you look at banks and hospitals, you might suspect something else. But also I've done a lot of casinos, so meaning casinos as physical casinos globally. Why casinos? Because there's actually a lot of similarities between casinos and many of the other financial services. So the data flow has a lot of money attached. So it has to be also secure and it has to be performant. So given that background, so talking about relational databases, so maybe the question is, what is a data lake compared to traditional databases? So let's look at the definition a bit. So the definition for a data lake is that it's a centralized repository for structured and unstructured data. So in traditional relational databases, you would see columns, you would see rows, tuples, and you would have very traditional ways of data modeling. So you have rules like you should always have the data only once in your database to kind of match the relational database theory. So that is a very structured way of building data stores in relational side. Unstructured in this context means that it might be something completely different than your traditional relational databases. For example, the way that you store data, let's take like top scoring board for a new game. It might mean that way of storing the data changes over time. And you have to have a microsecond or millisecond latency retrieval, so basically fast retrieval for that data globally. And in some context, the relational database model doesn't function that well for that type of data store and retrieving of the data. So we have to think about, like, can we do something different? Unstructured data can be also different kinds of data stores. So meaning you can have videos, you can have pictures. Let's look at the kind of the Gen AI and AI ML tools. You might also generate a lot of new content on the storage end. So basically generating new content for the audience based on the feedback and input that they are giving. So the data lake definition also includes the idea of store data as it is. and also use open source file formats, and of course, look at the performance of different file formats. And how do you enable the direct analytics on those data sources? So if you look at companies, so you look at the enterprise-wide companies, it can be size of Amazon, it can be size of anything that you think about in the Finnish enterprise landscape, is that they have data coming in from multiple silos, and they aggregate that data quite heavily, and they want to have a multi-purpose for that data. So they would like to have a view over all the enterprise data they have. It's not given or granted that everybody has that already. So data lake is a new way of looking at the landscape of data across enterprises. So given the fact that we are seeing the boom of machine learning and AI, is that if you have that one lake, one accessible that shares, for example, the data governance and privacy and security settings, it also allows you to do a lot of machine learning, a lot of analytics on top of that data. So companies are moving away a lot from the purpose-built data stores and the traditional data warehouses to get faster results for complex queries. And they do also a lot of combination. So it means that they might be still holding on to their relational databases, but they are actually cataloging those databases on top of a data lake structure. So meaning that it still exists, that silo of data still exists, but there's a centralized data catalog. So metadata of that data somewhere in the infrastructure. So we do see a lot of companies still using both. So they use data lakes and purpose-built stores. And they may need to move between these systems. And that means that you probably do need a centralized catalog for everything. So how do you build a landscape that will cover the whole picture of what data assets you have? We'll talk about data assets a bit later on today. So think about it in context of what is the business purpose. So assetizing your data, of having different use cases for your data. Why are you storing it in any case? So let's ask a question of, okay, so we might understand what the data lake is all about, but why? So why are we using a data lake, and why is it actually interesting for us? So there's certain points that I would like to raise. One is that, remember when we have been talking about serverless applications and microservices and event-driven applications. So there's a pretty similar point here. So how do you actually decouple your storage from your traditional compute? So how do you compute and actually do something with your data? And how do you do that in a scalable manner? And how do you actually enable advanced analytics across your enterprise data, across your different data sources? And all of this put together is the fact that you want to reduce the complexity of any transformations, any business processing you are going to do on top of that data. So complexity meaning that where is the data stored? How do I get access to it? What is my catalog? How do I manage the security and governance side? So how do you kind of extend the data landscape you have? So if you look at it in ways of thinking about it in outside-in approach, so your data lives in different data stores, but you want to optimize it in ways that you have access to all of your data. And you can scale it if you need to scale it. So meaning that if you need more performance, you will have methods of doing so for all the data that you have in your enterprise. So let's say your data lake would need additional processing power. You should be able to easily decouple it from the actual storage that you're using. Then I will actually throw in something that I've been thinking about, and I would like to kind of highlight before we start looking at the different processing ways of that data lake. So one of the key things that is very often overlooked when people talk about data lakes is that think about permissions and think about the enterprise-wide landscape that you have. You have all this beautiful data that you have across your organization. You have collected, let's say, like decades and decades worth of data. But of course, you would like to also extend all the privileges that you have on top of that data so that they follow a certain rule set. So let's say if you're targeting to set permissions based on users, based on roles, based on organizational units, let's say you have a global organization and you want to say that Finland has access to data created in Finland and stored in certain structures, or let's say you want to give EMEA-wide teams or global teams access to all the global data, you should be able to do that easily using mechanisms that go across the whole data lake structure. But it's not always given. So that is something that in traditional architectures like relational databases has been quite tedious. So let's talk about the centralized permissions. So centralized permissions, when they relate to data lakes, the idea is that you have administrators that set up your permissions on your lake resources. So they can be databases, they can be specific tables, but they can also be columns, rows, and cells. So let's say I'm a user who's based in an enterprise organization in Finland, and I have certain roles attached to my user rights. So I have a user named Ursula, and I have certain rights that are fundamentally based on where I'm located and what's my business privilege level. So in order to make this easier for the admins, we should have one centralized repository of doing this. And we do, now that we are going to talk about the how do we define it in a data lake, and you will get to actually try it out yourself. So you have the permissions, you have the data catalog, so basically the metadata of data, what is located and where. And then we have a data lake storage. And then you have the authorization going between the catalog of resources. So let's say you have a user called Ursula, you have Ursula's user rights, and then you have catalog of resources. So let's say you have like customer records, you have HR records. Based on Ursula's rights, the lake underlying infra will authorize access, or of course can also deny access on those catalog objects. And those objects can be multiple different things. So they can be those structured or unstructured data sources. They can be tools like, let's say, machine learning, generative AI applications. But the data flow and the authorization flow will always be the same. So there won't be a difference if I'm accessing the same data through, let's say, machine learning, or if I'm accessing it through my data warehouse user interface, I'm using a SQL interface, I will always see the same data. And that is one of the fundamental, really, really important goals of having a centralized data lake, because the privileges don't change based on what tool you're using. But that will require a bit of work to get that permissions and security boundaries set up. But once you have them, they are actually completely transparent. So what does it mean? So let's look at the security permissions of a data lake. So they are quite simple. So you can control data access with grants and revokes. So it works a similar way as in traditional relational databases. So you can grant access and you can revoke access. And you can specify permissions for databases and tables and also columns. So getting to even row-based permissions. So you can also look at the permissions centrally. So look at the permissions of what's being granted to which roles, which organizational units, let's say which particular users. And that allows you to also debug if you're thinking that there might be an issue of, let's say if Ursula says, I can't see same data as my colleague here in Finland, we can actually start debugging it, looking at the centralized security boundaries and permissions. And the other side, the flip side of things that is very useful is that you can also audit all of the data access. So both debug and audit in one place. So fundamentally, let's say we have a table here that has columns, which are marketplace, customer ID, product ID. So basically we have a table that has purchases made by different customers from different marketplaces. And depending on user rights, let's say I'm user 1, I might have access to certain columns. And let's say if I'm user 2, I might have access to different columns. So the difference is that I can do very granular access control. So meaning that I can have row-level security policies. Why is this interesting and why am I highlighting this? In the past, this was really difficult to do. And I'm trying to give you an example of how I've seen it in the past couple of decades is that globally, there are a few companies and units and groups that will do row-level access control. And those are usually, let's say, they might be like police force, they might be governmental agencies. They have a legally based obligation to limit heavily the access on row levels. For example, in US, NSA was talking about heavily using row-level access control because they have such a different security privacy levels inside the whole organization. So depending on your security clearance, you would see different sets of data. The flip side, this is all cool. It has been existing for a long time already. In the past, you required a team to do this. So you had, let's say, 200 people inside NSA doing just the row-level, row-based tagging of resources, who gets access to what group they belong to. It's a huge undertaking. And now what data lakes are changing is the fact that you have that out of the box that used to require hundreds of people of doing that. So the industry is fundamentally changing. But the really cool side of things is that having a data lake and centralized security governance is that it moves into a transparent way of controlling what access do people have and having also one kind of pane of glass of how it works, how it's audited, and if there are any issues, you can debug those. So that is fundamentally very, very groundbreaking and changing the whole thing. And the whole idea of those security permissions and boundaries are inherited inside all the applications that you're using. For example, those machine learning generative AI tools. So it is out of the box built in the AWS infra that you can kind of detach it from the security boundaries. It's built in. So if we look at like cross-account usage, for example, this is a good kind of an example of, let's say you're having cross-account boundaries and you have security controls and you have a data lake. So let's look at it as an example. So you have resources like your sales database and your, let's say, like sales opportunities table. And you have those permissions, those grants inside your data lake. So you give grants to opportunities tables to consumers that are actually in another account. So they are outside of that enterprise's AWS infra. So we can do something called cross-account sharing. So we give them access to a data catalog objects. In this context, it would be the opportunities. So meaning sales opportunities, and then we can create something that are seen as soft links. So we have resource links. So let's say that we have a specific group of opportunities inside EU. We can create a soft link or a soft resource, a resource link that is EU sales, EU opportunities. And we can define those links to shared resources. So it is a data lake administrator's task to delegate those access to users and also share across the account boundaries. And what does it mean? Like eventually it means that all the tools that you have, let's say like Amazon Athena is a tool where you can use SQL language to query multiple sources in the data lake. Glue is the ETL processing tool. We will talk about these a lot today. EMR is big data tooling, like complex analysis, and then we have like data warehousing, such as Amazon Redshift. Those are not the only tools, of course, but some of the tools. So all of those tools can use the same soft links, so the resource links, to access those resources. And all the permission boundaries will follow beautifully, so they're fully transparent there. So those of you who have been a part of the journey of talking about like cloud practitioner and have been taking part in the earlier sessions, you know that the security boundaries are attached to something called IAM, Identity Access Management inside AWS. So if you look at the data lake and you look at IAM, it's that it is attached to IAM. So you have the opportunity to have temporary credentials, you can create fully new permissions, you can do roles, you can do user-based permissions. So there's a multiple options of defining this. So the thing is, when you look at, if you're looking at the certification exam, what might be tricky is that one way of answering a question in the certification exam, so let's say giving permissions, doing, let's say, like the soft links and resource access, that may not be the only way of doing it. So you kind of have to go through a list in your mind of like, yeah, I can do it with tools like IAM, I can do it with temporary credentials, I can do it with different things, and that might give you a bit more to think about before you go into the exam, that have you actually covered all the levels that you need to understand. So we will be doing the prep for you, and we will talk about the different models, but I will also give you a bit of extra material to read through. So if we keep in the context of data lake, so let's look at the lake and lake security request flow, what it looks like. So let's take a simple example of that. So so if you have a principle such as IAM users, or let's say IAM role, so you might have the user of Ursula, or you might have a role of, let's say, Enterprise Organization Finland, and you have a directory of users. They can be, you can have your, let's say, your Active Directories, you can have your Cognito user directories. It doesn't really matter, but let's say you have active users and you have those services. You have different services that are those databases or tools like such as Athena. And once the user queries something, and we are looking at, do they have access to resources? So once we go into the resources, we look at something called a data catalog. So we can request an access to resource. Let's say the resource name is T. That could be like the sales database or sales opportunities. The lake catalog will give us a short-term credentials for if the user has those accesses granted. So if they don't have, that's a immediate denial. If they have access, they will have short-term credentials, tokens that they can use in order to access the resource. What happens next is that those credentials are put into requests to objects, and those objects can be, let's say, they can be inside those S3 buckets, they can be inside a relational database engine, they can be in a multitude of different locations. But the cool thing is that the lake formation and the lake catalog knows about those resources. So it knows explicitly what's being asked. So then we can request the data from those objects. And then we return those objects from that given catalog and that given data store. How does it look like if we go into the kind of the authorization or authentication side? I will not go into very deeply into it, but I will show you just like a simplified example of that. So I have 2 slides on this one. So if you put in IAM into that, so keep in mind, so remember the fundamental thing about AWS is the fact that anything you do in the console, anything that you do in the infra, everything is an API call. So you can't do anything on the infra without having an API call or request attached. So we can start by the fact that regardless if you're using a CLI, so command line interface, if you're using your console to access it, if you're using things like, I don't know, like programmatic access of CloudFormation, each and everything you're executing on top of AWS is an API request or call. So if we look at IAM, so it starts with an API call or request. It goes through authentication. So authentication meaning that we need to identify some of the principles. So we will identify the password. So it might be Ursula's password, or it could be a secret key that we sign that API requests with. What's the difference? So if I'm a physical user just typing away at my console, it means that I typically will have Ursula's password. If I'm a programmatic access code interface, anything of sorts, it might mean that I have a secret key that is encrypted and used to sign my API requests. Or let's say I could go through like an Active Directory or SAML authentication method. So there's multiple ways of doing this, but we have to do authentication in order to see if we can access the resources. What happens next is the authorization of that request. So what happens on the authorization of the request is that we determine if that principal, so in this context, that could be Ursula, has access to those requested resources or APIs. And those are based on certain things. So they can be your IAM policies that define what access Ursula has or doesn't have. Resource policies. So resource policies can go across even organizations. So if you belong to an organization, they can do like organizational unit level policies that says employees in Finland will have these default settings for their accounts. Let's say that you use like tagging for your rows. It might mean that access that sees that the principal, the user is coming from the organization of Finland or that organizational unit of Finland will have access to these resources by default. And then you have, of course, tag-based policies that might mean that we tag certain resources based on row values, for example, and that means that they will either have access or don't have access. One really important thing that is good to keep in mind, if you have an explicit deny, so if we say Ursula doesn't have access to sales records, so let's try with that, will always revert to a default of deny. So explicit deny will always prioritize over a grant. So if you have said that person, that user, that principal will not have access, we will start with that and that will block access. So if you're seeing issues where somebody says, hey, I can't access this, have a look at, have you put in a deny somewhere? If you have, that is the default. So the reason why it's a default is that we will always limit access to the minimum required. And defining minimum means that deny always overrides grant. So just one more thing. So one more slide on the authorization part. So looking at the big picture, so looking at the Lake side of things, so going from API call request, authentication, and then using those either password, secret keys or such, you get to the authorization, you have those policies. And then when you get to the Lake side of things, so you get to the data lake side of authorization, the Lake side catalog and access controls look at the metadata. So the metadata meaning what is the table name, what is the resource name that's being queried, and you have a tool to define those permission boundaries inside those Lake tools. So you have either granted or revoked access, and you can do so via using the console or APIs, the command line interface. So you always have the three options of you can do everything. Everything is always an API call fundamentally, but you can do it in console, you can do it in command line interface, or you can have a direct API call. And that will always be transparent when using a data lake for the whole organization. So you can't bypass those permission boundaries by actually having, let's say, another tool that you would use, because it will always attach to the same central storage. So that is in a very compact way of talking about security. That will be kind of the biggest part of security we will talk about today. Then let's look at the tooling, and let's look at what is now fundamentally different when you compare to the way that we used to work with relational databases and also analytics tools. So let's look at the past just a little bit. So, hang on. So traditionally, if you look at the data analytics and you look at the different data sources, so your relational databases, it didn't really matter. You might have had like terabytes or even exabytes of data. You had a very strict way of defining a data schema. So what are the objects? What are the relationships between the data objects? Are they one-to-one, one-to-many, many-to-many relationships? So the data modeling way was kind of strict. And then, of course, we had ways of modeling things like data warehouses and denormalizing data, even having a duplicates of data due to performance. But it was very similar in ways of you had the business intelligence tools at the top and you had the data warehouses or relational databases, and you had the relational database layers of having like a fully operational data, having your ERP data, customer relationship management. So kind of siloed way of looking at the data sources. And one of the challenges that we have seen a lot in the past is the fact that there's a usually quite large upfront investment. So CapEx and based on how much storage you use, like terabytes per year, etc. The thing that has changed over the years now is that if we go back to the times when I was starting my a career in IT, the storage was one of the most expensive building blocks, but it's not anymore. So also looking at the data stores and relational databases this way is kind of old-fashioned because it's not the most expensive component. Storage is actually getting to be one of the cheapest components. So could we actually utilize the fact that we have cheap storage, and then we need to find the best ways of collecting the data and getting to the data in the most performant way? And that might mean that we also sometimes do duplicate the data in different formats because we can store it in different formats. So the thing that we do see that the data volumes are increasing continuously. So basically the data industry is booming. So it has been exploding from terabytes to petabytes to even exabytes. And like I mentioned, starting my career, when we talked about large databases, so we said something is a large or very large database, we might have referred to databases such as, let's say, hundreds of gigabytes of data. In these days, hundreds of gigabytes of data is nothing. So to talk about very large databases, you typically talk about already exabytes and sometimes even petabytes of data. So that is a fundamentally huge shift. And the fact that the storage is getting cheaper. So if we look at data lakes, the data lake actually extends the traditional approach from terabytes to exabytes to petabytes. And the fundamental difference is also that you will have a main storage of metadata, metadata being the data of data. So what do you have? Where is it stored? How do you access it? Who can access it? What is the permission boundaries of that data? So the data lake behaves as a single source of truth, and it can be relational, it can be non-relational. And it can also very easily decouple the storage and compute by giving you access of very cheap storage and also layered storage. So what does a layered storage mean in this context? So layered storage means that, let's say you're collecting data inside your enterprise organization for years and years and years. Let's say you have decades of data. The data that you have from 20 years ago might mean that you don't need to query it constantly, but you need to store it if you need to store it. So you need to store it, let's say that it's your human resources records. You might need to store it for legal purposes for indefinite amount of time. So, but you know that it won't be queried that often. The layered storage means that the data that you will be most likely accessing most often will be on the level of fast retrieval. The data that you will be seldom accessing can be stored on a cheaper storage level. We are still not jeopardizing the fact that it will be cheaper in ways that we might lose the storage. So it will be always enterprise grade way of storing it so that you will have the ways of having multiple copies of the data. So you can always get to your data, but do you need to get to it immediately? So if you don't need to get to it immediately, you can actually scale down on different tiers of storage by going into the archival mode. And that makes the cost per terabyte or gigabyte much cheaper. So that allows you to also scale down the cost for the whole enterprise. So that is the idea of also having the lower cost of storage when you need to have multiple decades worth of data. You can also have schema on read, so meaning that you can have flexible schemas, so you can have multiple different ways of modeling the schema and also combining data. And you can use diverse analytical engines, and you can actually combine analytical engines with machine learning algorithms. So let's say that you have your traditional analytical engines of having your typical, let's say, reporting interfaces, graphical user interfaces. You can also combine it with things like machine learning, such as vector databases. So how do you model outputs of your data for analytics using analysis on words? What words do usually occur together? And you can use multitude of things for the same data lake structure from multiple sources. So let's look at the benefits. So let's see what the benefits are. And traditionally, what you will see in the exam, those of you that will do the exam, you will see questions on why a data lake. So very, very basic questions of why should you use a data lake? What is the benefit? So one is the fact that all data or the data catalog in one place. So if you have those questions in traditional enterprises, so why is the data distributed in many, many locations? Why do we have these silos? Why is one server in Germany and one is in Finland and one is we don't know where? How do you actually combine it in one place? And how do you have that catalog in one place? And also, how do you store and analyze all of your data from all of your sources in one centralized location? And then if we look at the side of, so these are really general ways of talking about a data lake. What about pulling in data in the data lake? So we know that the data flow inside organizations is accelerating. So let's take a large enterprise organization. One of the questions could be about quick ingesting of data. So how can I collect data quickly from various different sources and store it efficiently? One of the reality checks that I have actually noticed even today, regardless of all the beautiful and bright tools that we have right now, a large portion of the traditional organizations still use very, very traditional tools of ingesting data. So you have tools like SFTP, where files are dropped in a store, and then that is ingested into different data stores. So the tools in that way is not evolving that quickly. Of course, there are organizations that use API-based real-time data ingestion. Let's say in our context, that would mean like different kinds of real-time data processing that will have also real-time transformational tools. But a lot of the organizations still pull data as CSV files, so comma-separated files, and they will ingest data from that point onward into their data lake or into their relational databases. So it's not evolving that quickly. If you look at the data ingestion, you also have the requirement of at least the aspiration from many of the organizations to quickly take in the data without having to force it automatically into a predefined schema. So there's a lot of need with different organizations to say, like, we need to get the data in as raw data because the storage is cheap. And then we can ingest it further or transform it further, but we want to also hold on to the actual raw data. Question is why? So what is the benefit of holding on to the raw data? So one thing is that we now can, because the storage is not going to kill us with the cost. So let's say that once we are pulling in data, And typically when we are pulling in data, the first line of storage will be S3 buckets. Those of you who have taken part in the Cloud Practitioner, remember that S3 storage is fundamentally the first service we have ever launched inside AWS. And that is an object storage. If you can hold on to the raw data, and let's say that you have a lot of, let's say, IoT data coming in. If you have a lot of raw IoT data coming in, it's mathematically more likely that you will have better calculations if you can revert back to the raw data of checking if your calculations are correct. If you, for storage purposes, have to take in aggregated data, so for some reason you can't store all the raw data, that might mean that the aggregation loses a part of the granularity of your calculation. So if you take, let's say, day, week, or month-based data from your sales records across the globe, if you have to revert back, is the differences between the organization of different countries, you can't do so when it's aggregated. So in order to check your results, you would like to have the raw data still available. Of course, not all the use cases will require this. So some of the organizations do aggregate beautifully and it works well. But for complex analysis, it's good to have access to the raw data and then actually transform it from there onwards. So what is the benefit of a data lake when you look at the storage versus compute? So one question that we typically get, how can I scale up the volume of data that is being generated? So let's say you're merging two enterprise organizations and you're starting to merge there also the technical infras. How can you scale up the volume so that, let's say that the volume is increasing by 10-fold? How do you keep up with that pace? What about if you have to get into the real-time data processing? So the real-time meaning that the streams coming in need to be processed immediately when they are in. So Data Lake also has tools for that. So you can actually use certain tools that are fully real-time. And also given the fact that the storage is not the biggest expensive component of your stack, you can easily scale your storage using different tiers of storage. So you can separate your storage and compute, allowing you to scale different components as required. So it works as microservices. So remember when we talked about microservices, you can scale the components that you need to scale. You don't need to scale the whole stack in one go. So one last benefit, and then we'll talk about building a data lake. And the examples I will give you today will be the ones for those of you who will do the exercise also. So you don't have to, remember, you don't have to do the exercise if you don't want to do the hands-on part, but you can do so. I will give you accounts for that. But let's look at the last benefit. As I mentioned, schema on read. So is there a way I can apply multiple analytics and processing frameworks on the same data that we have coming in? So looking at data lakes and comparing it to traditional way of data analytics is that we have more agility. So we can get faster to insights from our data. And we can do experimentation faster at a lower cost point because we have separated the storage from the compute. We also have broader access to data. So thinking about having the raw data, having the aggregated data, and then maybe going forward using different tools and different analysis methods in there. So you have broader access to data, and those access rights are inherited across the stack. So it gives you more flexibility to deal with the data variety. And the fact is data variety is growing really significantly. So data variety meaning that, let's look at like an industrial example. So let's take your like manufacturing environment. You might have a lot of real-time data coming in from sensors. So IoT sensors, for example. So those sensors are pushing in data that is basically row-based, and they might be something that we will calculate with. But those customers, those manufacturing sites will start producing, eventually all of them will start producing things like video stream. So what's happening on the factory floor? pictures. You might have work safety related things that you want to collect from your factory sites. And you might have also, let's say, audio stream from factory floor if you need to do like analytics of what's happening, or is the machinery working as we expect? Is the sound level changing? Is there something that we can expect that there will be changes or even faults in the machinery? So given that we will have different variety of data, we need to be also able to process them in different streams. So that is one of the benefits of having flexible schemas. So you can actually attach ad hoc analysis by applying different ways of different schemas on those data that you're getting in. And meaning that once you're reading the data, you can do that and already get that in the ingestion phase. So those are the benefits. Those are typical benefits that also the certification exam will talk about. Then let's look at the practicalities. So let's look at building a data lake, and all of these components that I will talk about, you will have access to in the exercise environment. So building a data lake, and I think somebody asked in the previous sessions, so anything that we talk about, could I use this on different cloud vendor environments? So regardless of what you're using. So there's a multitude of clouds available. I would say a big portion of what we are talking about will be very similar. Of course, not all the tools and tool names will be similar, but you will most likely have very similar stack, very similar principles. So you can use this also in different cloud environments. And also I would encourage you, if you're thinking about what will be my next career step, so please do compare. So we offer also free tier of services. And I would say many of the different cloud vendors do that. So be curious and look at what are the differences. What do you like? What do you don't like? So that is very useful when you're thinking about what is the next step that you're going to have in your career, when you can say, hey, I compared this. So I did this on AWS and I have done this in X, Y, and Z cloud environment. I know the differences. That is fantastically valuable when you're applying for a role. So of course, I will talk about AWS and I will talk about implementing on AWS. So let's take the building blocks. So let's take like 1 to 5. So when we are implementing a data lake architecture, we do require a set of tools. And we will use different technologies inside AWS to provide different applications and support for different use cases. But the fundamental pieces or the typical steps for building a data lake on AWS is that we will start with the storage, and thinking about what the storage size might be, we have to look at how do we make it scale. We can start by having some gigs of data, but what about if we get to hundreds of gigs, terabytes, exabytes, petabytes? So understanding what the cost will be. So, and I will soon share what I typically use and what I combine it with. Then the second part is how do we move data? So how do we ingest the data into the data lake structure? How do we cleanse the data and prep and catalog the data? So how does the data lake metadata catalog know what's in there? So let's say if we are bringing in the sales database and we are bringing in so the different marketplace data, how do we know what those are called? How do the users know what those are called? And how do they get access, and how do we do the authorization for those? And then how do we specifically configure and enforce the security and compliance and governance rules? And also, how do we make the data available for the analytic applications, or let's say like the machine learning, AI, generative AI tools? So how do we make it available? Because if it's not available, even if we store it, it's probably useless, because we need to be able to use it to benefit the organization. So let's start with the storage and build it from there. So the fundamental piece of building a data lake is fundamentally based on S3. And S3 is often overlooked when you look at the infra. So people say, yeah, we have the object storage, but actually it has much more inside of it. So remember, we have talked about the durability of the S3 storage. So durability meaning that when you put an object, a file into the S3, the durability is always on a level that we know if we are using S3 standard or if we are doing durability on a level of having the multiple availability zones, we have a guaranteed grade of durability. So kind of looking at the fact that what would be the likelihood of losing data. So it would be very highly unlikely. So it would need a global scale catastrophe in order to lose data from S3. It grows into the exabyte and petabyte scale. And it's also having those built-in rules of security, compliance, and auditable ways of handling the data. And what is often overlooked is that it is actually behaving also like a database. So it has the possibility to look at the data as it would be stored in a relational database or a similar manner. You can also get to a level of looking at object level controls, of having fine-grained access. So you can actually look at the object control such as who has access to which rows. You have things like versioning. So you can look at versioning of storing multiple versions of that data. So knowing how the data has evolved across time. And also you can retrieve subsets of data quickly. So meaning that you don't always have to collect the whole object or the whole bunch of objects. You can actually have a performant way of retrieving subset of data. I will talk about performance tuning just a bit today. And that means that you can decouple the compute and storage. So it's not attached to each other. So it doesn't have to scale together. So you have different on-demand resources. You have that storage tiering, and you have different cost choices. And around the S3, you will have a multitude of tools. So you can have multitude of tools of bringing in the data, like standard ways of bringing in the data. And you can do real time, you can do near real time, and then you can actually query it with different tools of looking at tools like comprehend. So how do you understand the language itself that is used in the data itself? Or let's say you have images, how do you do image recognition on top of S3? Or let's say using machine learning, large language models, you can do so on top of S3. So that is the fundamental building block. So the question is, why would you use S3? One is, of course, cost control. The others are related to the different tiering options and performance. So if we put together the benefits of S3 is that one key is durability. So durability meaning that you have 11 nines of durability. And what is it based on? Those of you that took part in the practitioner remember that once you put in an object in S3, it actually does duplicate it in multiple availability zones. So that's happening behind the scenes. And because the cost of the storage is low, you can actually hold on to a lot of the data if you want to store it for your enterprise, for history, for legislation purposes, for policy purposes. And you can also do replication between regions. So if you want to, for example, for availability for different global regions, have access from different locations, you can do a cross-region replication settings. And it scales quite well. You have multitude of ways of bringing in the data, and you have the API calls, you have the software development kits that you can integrate to S3, and you can have event notifications. Event notification is interesting. It will be, I would say that I could almost guarantee that if you're going to do the certification exam, you will at least have one question on event notification. What does event notification mean? So let's say you're putting in files in your S3 bucket. The event notification might be a notification that somebody put a file into the bucket. The event notification might trigger an action. So it means that triggering an action from, let's say, putting in an object, getting an object, removing an object, means that we can have that serverless way or serverless approach of having event-driven architectures. So you can attach your programmatic approach to events happening on top of the S3 layer. And the reason I said you most likely will see this as an exam question, you will get a typical question of, hey, an organization wants to use a scalable storage and object storage to pull in data, but they want to be sure that once the object is in the storage, let's say a object transformation will happen. And how do you do this? There's, of course, multiple ways of doing this, but the exam question might hold an answer to it. So there might be a fact that you don't want to do like fully real-time data processing, or you want to do the cheapest option. Most likely, in many of the cases, you will talk about an S3 event notification services, because it's such a fundamental and cheap way of doing event-driven architectures. And then, of course, scalability. So you can scale the storage and compute independently and store as much as data as you need, and have those different tierings of moving the older data that is rarely accessed to cheaper storage levels, such as archives. We have AWS S3 Glacier. You have Glacier where you can always retrieve it quickly, but that will have a cost attached. Or let's say that you will have infrequent access. That will mean that the retrieving data might be a bit slower, but then it's more, it's cheaper to use per gigabyte and per terabyte. And then it integrates to a lot of services. So S3 is a fundamental piece in many of the services that we use. So when you're building a data lake, so we have that storage piece. What about the actual lake architecture? So the lake layer of having those metadatas in. So you might have other services, of course. So you might have the relational databases, you might have different search tools. So let's look at them a bit. So lakehouse architecture. So you might have, so you remember last session talked about purpose-built data services. So you have the S3 in the middle, and you have a lake formation tool that will define the different borders for your data lake. So how do you create a scalable data lake? So you can use certain tools. Let's say you need relational databases. Let's say you have your ERP application, your traditional way of approaching, let's say, customer relationship management applications. Those might very well function the best on top of a relational database. So you might have your Amazon Aurora, which is a relational database engine. You might have your RDS engines. You might have your SQL servers, Oracle databases, and they all actually attach to the same architecture of lakehouse architecture on AWS. How does that happen? That happens based on cataloging the data and different data sources. So the providers of, let's say, S3, having those Oracle databases, having your NoSQL databases like DynamoDB, and having a catalog of all of those, and having the seamless data movement in between, and even doing queries that will combine multiple sources. And that catalog will host the names and accessibility, the awareness what's in there. So starting from S3, so you start with S3, you might have that raw data available, and then you can push to different database services, relational or non-relational. Then you can combine it with different search tools. So having Elasticsearch, or let's say data warehousing solutions like Redshift. So if you want to model in a more complex way of having more analytical power, and let's say different algorithms, filters. Let's say you're using a lot of Bloom filters, different kind of predictive ways of looking at your data. You will most likely push certain data sets from S3 onwards to those engines. So you will need to use the right tool for the job that will provide you with the lowest possible cost point. So what is the tool that's being used in top of all of this to move the data? And here also, I would like to remind you, when you're looking at the exam questions, you might have multiple tools, but very typical one will be AWS Glue. So AWS Glue is a tool that you will use for most of the practices that you will do on top of the immersion days that we are going to run for you, including the one that I will give you today. And what is the benefit of using AWS Glue is that it's a serverless way of doing data integration, so data movement, transformation inside a data lake architecture inside AWS. You might hear that there are different tools. You could do even your own transformational tools of using different kinds of scripts and things. The reason Glue is really cool is the fact that it has support for multiple languages, multiple transformations. So if you have your Python code that is already doing something, you can actually integrate it with the Glue and with different tasks and log levels. So it actually integrates with existing code really nicely. So that is a tool that we will be using for data movement. And also, if you look at the lake formation itself, how do you manage the security and governance? Who has access to what and how do you keep it transparent inside the data lake and different purpose-built stores? So let's look at the scalability of that data lake. So some of the things that will be on the next slide, we have already talked about. So one thing is, how do you start building quickly? And you will see in the exercise I will be giving you, you will get to end result fairly quickly. It is quite a long exercise. So if you would do everything back to back and you have never tried any of the lake formation tools, you might need in total of 8 hours. So I know that's long, but it will go through all the things that we are talking about today. So how do you start from S3? How do you do the cataloging? How do you do the ingestion of the data? How do you combine it with tools? How do you do different kinds of queries? So in essence, in 8 hours to build an enterprise level data lake, it's not that bad. So lake formation itself will also simplify certain things. So we'll give you one user interface to do things like security management. And one that I haven't mentioned yet, let's look at the enterprise that has hundreds of users, hundreds of employees. One thing that we are leaning heavily towards is the fact that you want to give the correct people the correct access to have self-service access to data. So if I'm allowed and authorized to use data, I should have the access to use different tools to analyze, to look at the data without having to raise like multiple requests of somebody else collecting it. So the lake formation tool will also give you the possibility to give your end users more autonomy to do their job. So actually having those data sets and still staying inside the permission boundary that they have for their role. So looking at the user interfaces and how it looks like in the cloud and how it looks like in our console side, the flow of different tools that you will be using on a fundamental way for lake formation is basically that you will have your data sources like S3 with raw data. You might have those relational database instances, and you might have those non-relational database instances. And then you have different layers on the lake formation side. So you have something called crawlers, and we'll talk about crawlers very soon, what they do. Crawling data sets and also finding new objects if there's something being created in the infra that you have. How do you do the data transformation and prep the data for usage for different purposes? How do you keep up the data catalog, and how do you do security settings and access control? So those will then follow up and get you into actually having those different tools. And tools can be SQL-based tools. So for example, Athena is a SQL-based tool that allows you to query the data. For example, if you're working for the data analytics team, if you're working for, let's say, your financial side in the organization, and you need to get to the raw data and look at the raw data, do different calculations, you could maybe use Athena. You could also use different machine learning tools. Then you might have your Redshift data warehousing with different algorithms and with different filters. And of course, getting to much more advanced, like big data analytics, you would have like Amazon EMR. Those are not the only tools, but those are like a subset of tools. One thing that people often overlook is that when we talk about the lake formation architecture, you can take the same architecture and turn it into purpose-built data lake. And I will mention a couple, and these are not the only ones. I will just briefly mention that there is something called Amazon Health Lake. And Amazon Health Lake is also a data lake, and it works in a similar way as we have talked about. So of course, having those access controls, having those users, having those ingestion of data. But the idea it's actually based on is that it's also following the legislation that it needs to follow in order to be a purpose-built store for storing health data, like HIPAA eligible service. So there is certain services doing this, Health Lake being one. There's also Security Lake. If you look at the things like NIST framework, how do you do cybersecurity frameworks on top of S3 and data lake services? So that is definitely one subset that we see a lot of. So you could have a specialized data lake that is already built in the AWS infra, or then you can build your own purpose-built version of it. So let's look at what you can do with the data lake. So let's go through certain examples, and these will be the tools that you get to experiment with. So let's look at the what can you do with it. So the most simple example, and the one that you see a lot in the exams, is how do you query from a data lake using query tools. And Amazon Athena is one of the most fundamental tools that you see being used. And the reason why it's very usable is the fact that it integrates with all the services and fundamental building blocks really nicely. It's also a serverless approach. You can also do different kinds of workbooks inside it. So meaning that you can have separation of roles and also authorizations, meaning that certain subsets of data or roles or analyst roles are only available in different workbooks and environments. So you can kind of pre-create certain things that will be easier for the employees to onboard in your organization if you know what the role needs to do typically. So having a subset of data and having those access controls already in place. And it looks like a very traditional, if you're used to relational databases, how to query them, it looks like a very, very traditional tool. Thing is, this will access all the subset of data, having those access controls in place that you have in your relational databases or you have in your S3, and it behaves like a relational database, even if it's querying multiple sources. So it can combine sources and the metadata catalog from your data lake. So that is one of the most typical tools. You will have questions on this in the exam of, let's say, if you're seeing different end results than your colleague, what might be the underlying reason? So remember those access controls, authorizations. So it will always be transparent in ways, even if we query the same table. So if I'm querying our customer orders, my colleague next to me is querying customer orders, we see a different subset of data. Typically, it means we have different user rights. So if I would see only the orders from Finland and they would see the orders from the whole Europe, it means that they have more access than I do. So that is one typical tool, and you get to experience that in the test environment and in the exercises. What about analyzing the data and looking at more like graphical user interface side? So we have tools like Hadoop on Amazon EMR. So looking at the big data approach, having different clustered approaches for data, doing visualizations, mapping the data into different mapping points. What about if you don't want to do something as complex as big data, or you don't necessarily know how to use different algorithms on top of big data, or the business need is not that heavy? Another way of visualizing the data is Amazon QuickSight. So how do you do quick visualization is a tool called Amazon QuickSight. and it attaches to the same data lake structure. So you can do different mappings from your data. You have the same catalog, and you can actually currently, if you look at the quick site that you will have access to, you also notice that there's a lot of machine learning capabilities attached. One of the ones I really like myself is that, let's say I have my set of data. I will do all my visualizations, like I have all my pie charts and all my calculations in there. And then I say, oh, I would like to create a PowerPoint from this. You now have tools called Amazon Q that you can actually say, Amazon Q for QuickSight, create a PowerPoint deck for me from my visualizations, and it will create the deck with all the visualizations in there automatically for you. So then you can actually add your text and whatever you want to do in there. So it integrates with multitude of tools, and of course, having those security boundaries in place. So those are the typical querying tools, visualization tools. But what about the clue? And what about the central data catalog? So let's look at the catalog a bit, and then we'll look at machine learning. So if you think about the data catalog, so what the data catalog fundamentally is that it's a collection of data sources, so multiple data sources, having those relational databases, having those tables, having those NoSQL databases, and listing those based on their database, their location, their classification. And in this screen, I know it's really small, but you will see that there are, for example, there will be a schema database, let's say legislators, and you will see that it's attaching to a location that is an S3 location. So that is a bucket. And the file type is a CSV or JSON file. And then you have Parquet files. You also might have connections to relational databases, let's say an Oracle database. So the location would be different. So it would be a relational database table. So you have these catalog different sources of data, and they are accessible based on the user rights that you provide. So that is also a graphical user interface of cataloging the data. Then you can actually decide to do different jobs with the data of transforming it, moving it, making it available for, let's say, machine learning algorithms, and also doing all the security controls around it by doing a centralized tool on the data catalog. Two more things about working with the data lake, and then we'll move a bit deeper into the mechanisms of working with it, and then a bit of performance tuning, and then I think we pretty much are on time for the day. So for machine learning, you can use your data in your data lake with Amazon SageMaker. So for example, if you want to start training your data, training your machine learning models, you can decide to attach to your data in your data lake with your user rights and using different, for example, Jupyter notebooks of including certain data sets and looking at the data and doing different analytical things with the data. So the integration is similar as with any QuickSight, Amazon Athena, EMR. So the same tool set is available. Now you're just using it to do machine learning. So those are the tools I want to highlight. Those are also the tools that you might have questions on in the exam. And that is the reason I want to encourage you to try out those tools. Before we move into looking at like optimization of those resources, let's talk about loading data from your data lake into downstream services. So loading data into downstream services could mean that you want to take your data from your S3 and you want to push it through, let's say, Amazon Redshift, so data warehouses, or let's say Amazon Aurora with MySQL or PostgreSQL, or for that matter, it can be Amazon RDS, so having those RDS, different flavors, databases, SQL servers, having Oracle databases, having your MariaDB, MySQL, Postgres, whatnot. So you can use the same data, transform it and push it into downstream services. So it can have a data flow, it can have interim places inside your architecture. And of course, the things like DynamoDB, so non-structured NoSQL databases can also be seen as a downstream service. And why not having those machine learning models as a downstream service? So the flow can have multitude of directions. You can also have kind of cross-directional, so getting from the Redshift back to S3, having different sets of already aggregated data. So S3 can loop into your process in a multitude of places. So a couple of things I want to do before we end for today is let's talk about a bit deeper about the working within the data lake. And I picked certain topics there. We don't have to do them all, but some of them. So one is the optimization for cost and performance. So that is a very typical question that we see. So now that I have all my data sets in S3 and I want to optimize them for, let's say, be more cost efficient, or let's say being faster to query, what are the tools that I can use for that? So I will show you a couple of things. These are quite basic. Once we get to the more advanced, so once we get to, I think it's in January, we have a session, we actually have two sessions. One of them is ETL and one of them is advanced ETL. We will talk a lot more about cost control and performance, but these are the fundamental pieces. So optimization for cost and performance. If we just list three things, is that I would like to mention that we can, on top of S3, do partitioning. And partitioning meaning that we can split the data in sets that we don't have to scan all the data to get to our end results. And depending on what the tools you're using, so you can have your S3 and you can do fundamental partitioning in there. You can also do partitioning in different relational databases and of course in your NoSQL environments. But the idea is the same. You want to get to the subset of data quickly and you want to bypass the sets of data that will not be relatable to our use case. We'll talk about a bit more about that and the benefits of using partitioning. Then we have compression. So how do you compress your data? And this also functions in S3, but it functions in relational databases, non-relational databases. So how do you compress the data set that you have? And how do you weigh the benefits, like the pros and cons of what will happen if you compress? Talking about pros and cons, I have a couple of charts that I will show you. So let's say you have a data set that is in total like a terabyte range. If you compress it, of course, you're paying for less storage. That is cool. But if you're paying for less storage and then you want to query the data, it probably means that you have to uncompress it at some point. So what is the performance impact of having that cost and performance balance? And also managed services, like how do you pay only for the things that you're using, like serverless products, only the capacity that you're using, not for the kind of promised capacity of I will always have it available. How can I use managed services that will only trigger cost for me if I'm using them? If they are dormant, not being used, that they would be not incurring cost. So those are the things that we need to talk about when we talk about cost and performance today. So quickly looking through the partitioning. So let's say I have a lot of data that has country information. I have countries like Great Britain, I have US, and I'm querying from my data lake and saying like, hey, I want to look at data that is from US. If I'm scanning through all the rows, it might be very, very inefficient to do so. So looking at the partitioning advantages of actually chopping up the data into pieces like countries allows me to actually directly go to the data set that has the US in there if I'm querying US data, like in this example I am. So the advantages is that I can get faster to the end result. So let me show you what the advantages could look like in numbers. So I have a table that is in my data lake, and I have non-partitioned and partitioned tables. And this table is right now 74 gigabytes. So it's not huge, but it's uncompressed right now in text format. So if I want to partition it, let's say I'm partitioning it, if it's my, let's say my order tables, if I want to partition it by my shipment date, for example. So looking at the date column, it might mean that I will end up having a lot of partitions. So I might have, like in this context for that data set, I have over 2000, so 2526 partitions. So you can restrict the amount of data that's being scanned when you query that data. So let's say you're using your Amazon Athena by doing SQL queries, and you have that query of having that shipment date, for example, there. And first of all, you will get your end result quicker, and it will be also cheaper for you to not to scan through all and everything. So if you compare the numbers, so when you look at the non-partitioned runtime, non-partitioned having all and everything without the partitions, it's about 10 seconds. When you partition it based on those rules that you will get the 2,500 partitions, you will cut down the query by, so it will be 2.16 seconds. And let's say looking at the data being scanned, if you want to scan data that is all and everything in the table, it will scan through all your 74.1 gigs. If you're having multiple partitions, so meaningful subsets of data, you will have about 30 megabytes to scan through, and it will impact the cost. So the cost from scanning all and everything is about 0.36 cents, and then of course partition is a lot less. So it will be faster and cheaper. The thing is, of course, partitioning means that you have to understand your data. So in order to understand your data, you need to know what is a meaningful partitioning exercise. So if you know that your organization is typically having things like, let's say, shipment date, order date, and they are pretty equal. So you might have pretty similar numbers of partitions happening and data inside those partitions. That might work really well. What about if you're looking at things that might not work that well, is that if the data is deviated a lot. So let's say that you have certain silos that will have a lot of the same value. It might still mean that when you're scanning certain set of data, you will scan a lot of data through. So you have to be also very careful with what terms and columns do you want to partition with. But remember, it's a balance between, of course, the exercise of doing the partitioning and the fact that it's performant, it's more performant and it's cheaper. What are the other options of doing cost control inside data lake? One is compression. This is a bit more trickier, even on a basic level, is that you can actually use compression to speed up your queries significantly. That's really cool and useful. You have different formats of speeding up your queries. So you have algorithms like gzip, bzip, etc., etc. And different compression rates, ratios of going from high compression to very high compression to low and such. And also, is it fast or slow to do so? And for what use case it works for. So your traditional like gzip works well if we have like raw storage on S3, or let's say you have bzip2 for very large files. And then again, if you're looking at like slow analytics or fast analytics, there might be differences. Let's look at the differences between like data scanned and cost. So if you look at the compression, so looking at like format of just pure raw text, if your size on S3 is currently like 1.15 terabytes, and also like going through all the data, your runtime would be around 4 minutes, and data being scanned is the full set of data. So it will have a cost of you if you're scanning through all of it. If you're compressing it and having different formats, you get to a smaller, compact version of your data. That means that your runtime is way faster and your data scan is less. And then again, you will end up having more performant way of working with it. And the cost control is there. But then again, looking at the fact that once you compress it, do you need to uncompress it at some point? So when do you need to uncompress it? What does work well with different analytics applications, or is it automatically transparent to the analytics application? So you have to look at things like larger files are usually better in the context of doing compression, and you typically have like faster listing operations, and of course the fact that less data scanned and fewer requests on Amazon S3 and less metadata to manage. But then again, do you offset that by having to uncompress a lot when you're processing certain data sets? So I would say that be careful about thinking about like, what are you doing with the data? Is it useful to compress? Are there any downsides of having the compression on? That being said, a lot of the relational databases also use compression. So looking at the traditional relational databases, having your like major vendors of SQL servers, Oracles, DB2s, having MySQL, all of them have some kind of compression way of doing things, and they will always have a matrix of comparing what is the pros and cons. So what does it impact when you're, for example, having to change the data set? So do you have to uncompress in order to change the data set? So that is really, really compact way of talking about performance. And like mentioned, we will talk about performance a lot more when we get to the much more complex ETL. Let's talk about the cataloging and transforming data. And then I just have a few more things, and then I will also give you access to the exercise environments. So cataloging and transforming data. Let's look at the fundamentally traditional way of doing this. This is like what has been done in the past. So in the past, a lot of the enterprises did their transforming of data and data jobs, ETL jobs, as hard-coded. So they had one way of processing certain data streams, data sources, and they were hard-coded. So it can be good, it can be bad. It's not very flexible. So let's look at the kind of good and bad of things. So in the past, it's been very traditional that over 90% of all the transformation job has been hard-coded and hand-coded also. So meaning that somebody actually will sit down and start hand-coding things. It's not very useful. So there are certain things that might be bad. There are certain things that might be good. It is error prone because there's human in the loop. It's a lot of work. So there's a lot of sources of change and schema changes and volume changes. So everything keeps changing. That being said, what can we do now that is different? And that is the approach that we will use in the data lake exercise that we will be doing after this session, and that is the Clue approach. So I know there's like a multitude of tools that we could do this with, but we will be using now Clue because it's one of the most typical ones. So what is AWS Clue? So it's a way to discover, categorize, and catalog your data. So to make it available and queryable across your organization and data sources. You can also use Clue to develop, so generate code, so you don't have to write it all by hand. And now that we have, of course, the boom of generative AI and AI tools, you will also have tools that will give you advice when you're doing like hand coding and hard coding, is that, hey, you have this in your code. Have you thought about changing it to certain parameters to make it more flexible? So there's a lot of tools that will help you now, even if you're doing hand coding. So you can generate code, you can enrich it, you can move between different data sources, and it supports a lot of different coding ways. And then you can deploy it. So running them as serverless, so paying for only what you use, having a fully managed platform, and how to scale out that code if you have to make it scale more wider in the organization. So you don't have resources that you need to provision saying that, hey, I'm provisioning like an ETL machine. No, you will have serverless way of approaching it. So making it event-driven, microservices based. So let's look at the components quickly. So components include data catalog. It will include job authoring. and it will include job execution, and this all in one means that is a job workflow. So starting with the catalog, so it's a Hive Metastore compatible data catalog, and you use something called crawlers that will automatically go into and extract metadata from tables. And it can also create table, and it can also create different structures to have more accessible combined views. And it integrates with all the tools that we have talked about. So Glue data catalog, hang on. So has the data discovery, it has different connections. Those are not the only ones that I mentioned here, but S3, RDS connections, JDBC, Redshift, DynamoDB. There's a lot of different connections. So if you can name it, probably it's in there. Then you have classification and identifying and parsing different files, and also versioning. So how do you version the table metadata of different schemas? So because your data sets and your tables and your environments will change over time, so you will also need a way to do versioning to understand what's happening with the data structure. So that data catalog that we create is actually queryable by many different services. So having that integrate with different services, having the similar view in different services. So features that you have for the crawlers, you will have the built-in classifiers detecting different file types like on S3, extracting schema, like the layout. How do you identify that there are partitions? So it's on demand and it's scheduled execution. And then you can, of course, build your own classifiers. So it might look something like this. So you have the different connections, you have the crawlers, you have the databases, you have the S3 files, and then you can look at different files, different database types, and you will see that in the catalog. So you will have ways of identifying what you're querying and where you're querying. So the data catalog has typically things like, hey, we have a JSON file. We can have also handwritten descriptions. We have a database like analytics database, location of that source, when it's updated, object count, etc., etc. So data of data. So it's metadata of existing data. And of course, the schema details. And version control also goes parallel alongside it. So you might have multiple versions of the same data. And those versions are detected automatically. So let's say that we are looking at something that is like partition, for example. So the table definition changes if we move into the like partitions inside your table structure. So let's say you have a bucket that holds data that has months or dates in there. So you can look at structured or semi-structured data with the same process. And data catalog will assign names, and we can also change the way that we show the names to our end users. So there's a lot that we can automate or is automated for us, like partition detection. So it registers like, hey, there's new partitions being created, and these are the files that are included in that partition. That makes, of course, for the end user, easier way of looking at like, how is the data behaving? Why are we seeing certain things? Then there was the job execution layer of things. So what about the job side or job workflow of Glue? So job authoring means that we can, for example, auto-generate typical ETL code, or we can build on open frameworks like using Python, using Scala, Apache, Spark. So it is very much developer-centric, and you can automate certain things. So you can pick a source. So let's say I'm picking a source that is an Aurora database. So I can take certain sources that we already have available, and then we can write the outputs to, for example, existing tables, or let's say we create new tables. So it depends on what we want to do. So we do job authoring. So we pick a source and then we pick a target, and then we can transform the data in the process. So for example, we can take columns in the target or the source that we're using and then transform them, combine them, whatever you might want to do with the data set that you have, doing different aggregations, calculations. And you can do it by applying transformations visually. So you can actually look at what is the task that I want to do. So I want to actually pick certain columns and I want to actually map them to different targets. I want to revert to them as different data types. I can do all of that by visually mapping them. And what happens in the background is it actually generates code for me. So once I have the mapping, it will show me the customization and the transformation graph that will happen, and it will provide you with Python or Scala code. And then you can have a trigger condition. When will this job flow be executed if we want to do this job flow? So the benefit is that you will have a graphical user interface that is quite relatable, and it can produce different languages of code, and of course give you also the transformation graph, what's happening, why is it happening, and also the trigger condition of when do you want to trigger that job. So what could it look like? So it makes it into human readable and also editable, so you can manually edit it still, even though you have generated it. And it makes it much easier to actually start changing and manipulating like complex structured and also semi-structured data. So it's very much customizable. And then you can use tools like GitHub. You can do code sharing with different ways. So it integrates with different tools. And then you can import modules. So you can actually say, I want to import a module that will do a certain task for me. So you can say like, hey, I want to bring in Python modules, Java, chars, any kind of configuration files. You can import them from S3. So that is quite nice. So that is pretty much it when you look at the Glue job authoring. There's a lot more when you start playing around with it. So remember, you will have 72 hours of access to those tools that I will be giving you today. So 72 hours, you will have access to play around with Glue and with data lakes and with everything that you want to play around with. So try it out, see how it works. And there's much more to it. Like mentioned, we have 2 more sessions on ETL processing, so I'm not trying to cover it all today. Maybe something to mention about the kind of the last components is that when you're running those jobs and doing like a job orchestration level, a few things. So testing, running, triggering jobs. So you can compose those jobs like globally across the organization with event-based dependencies. So a very simple event-based dependency would be somebody puts a file in S3 and that will trigger an ETL process. So that would be a very simple way of triggering action. It can be a Lambda trigger. It can be a data trigger, meaning that data that is put in a context of either database, like relational database, NoSQL database, or S3 has a value, and we want to trigger an action based on the actual row of data. Schedule-based, so very traditional like batch processing, so you can do time of day, like every time this hour will process everything. And you will see those questions in exams. So typically, what are the mechanisms of doing time-based, event-based, on-demand, and such. So you will have logs and alerts available in CloudWatch. Everything integrates nicely with the whole AWS infra. So a few things about the job still. You have job bookmarks. So Glue actually keeps track of data that is already being processed by a previous run of your ETL. So it's kind of a persistent stage of following up what's happening, and it's called a bookmark. So you can have options for bookmarks. So for example, enable, so pick up from where we left off. How do you stop or disable it? How do we pause? So how do we disable by not stopping completely? So kind of let's not advance, let's pause it and then continue. So let's say you get a lot of files in your S3 buckets, and your glue processes or jobs are keeping track of those files and keeps track of if they are processed already. So you can do so by using your job bookmarks, and that prevents you from having data duplication. There's a lot of metrics in the backend. So you have metrics, and you can enable a lot more in the command line interface and also the software development kits. And you can do like enable metrics commands in the parameters of your job. So you can have much more extensive parameters collected. And you have progress and history. So for example, if you see that you have a job that has a run ID and the run status is succeeded, you still will have logs on that, and you still will have the error logs on that. So you can look at what happened throughout the job. Or let's say you have a failed job that you can look at the same logs, what's happening, how it ran, did it run correctly? And all of this also allows you to do job monitoring. You can so publish the jobs. You can do different kinds of conditions in the jobs, like any all failed stop timeout. So what will happen if it fails? Do we trigger something else? And do you have like job timeouts? So you want to wait a certain interval before you continue with the next job flow. And keep in mind, all of this is serverless, like we talked about. So there's the job function or the job execution is serverless, and it's based on the same role and authorization, authentication mechanisms. And you can decide how much capacity gets allocated. So that's also a cost control mechanism. So you can basically automatically scale out resources, and you can pay for what you use only. So a quick picture on what the overall flow would look like is something like this. So with Glue, you would crawl your raw data, and then you would actually create your targets. What do you want to create from your transform data, and where do you want to create it from? Then you would generate and prep your ETL, and then you would actually execute your job. And like mentioned, you have multiple languages that you can use. Very typical one is a Python shell job. So it's very cost effective, very easy way of doing it. So that is pretty much it about the tooling and what you can do with data lake on a fundamental way. There will be a couple of exercises in the stack that I will give you now about also machine learning transformation. And that is a lot about what we are seeing right now, about if you want to, for example, find matches or similarities or like record matching. There's a lot of niceties that you can do with machine learning. That is a bit more advanced topics, and I will leave it so that you can play around with it. You have the tools in there that you can try, but we will look at it much more in the upcoming ETL sessions. So if we summarize a bit, so let's summarize a bit, and then I will give you access to your accounts. So on a summary level, data lake is not on all parts completely different on traditional approaches. So if you look at the traditional approaches, the fact is that it has been a bit siloed. So the fact that we are getting data lakes means that we are having the storage level as a separate from compute. And it allows us to also grow the storage level, have the different storage tiers. So basically having all data and data catalog in place. So basically having that single source of truth. And while you can still combine relational with non-relational data. So you can have queries that combine different sources, and you can have those flexible schemas, and you can also have the structured and non-structured data. And that allows you to use different engines on looking at the data, analyzing it with different tools. But in order for you to actually know how it works, I would say that it's a good idea to look at the environment, try it out. And that is the reason I'm going to give you access to the tools. So I will actually do so that I will also share the links in chat, or if Sanna, you have the links, you could also drop them into chat. So there will be practice accounts, and I will actually show you what's being included in the practices. And keep in mind, it's 72 hours accessible. So you will have, once I open it up, so I haven't opened it up yet, I will now do so. Once you access your account, it means you have 72 hours to do the exercises you want to do. So it's called an AWS serverless data lake jumpstart. So that's quite a mouthful, but what does it include? It actually gives you a way to do all of the glue niceties that we talked about with different environments. There's already some things that are being deployed for you, so you don't have to build all of it from scratch. So that would be a lot of work. But as an intro, you will have the Jumpstart will talk about acquiring data, staging the data, and then processing the data with Glue, having to do Glue data catalog, storing the data, exploring the data, and visualizing it. And then, of course, kind of the end user side of consuming it. You will have pretty much all the tools that we talked about today accessible. And the thing what I need to do before you can access it is that I need to start the event. So now that I will kick off the event, it means that now this is the starting point, and from this point onwards, you have 72 hours. Couple of things. If you are going to be doing the exercise, use always, even if you close down your browser and you exit the environment, and let's say tomorrow morning you want to continue, use the same email address that you have with that invitation link. Because if you're giving it another email, it tries to take another account, and it looks like that we are pretty much consuming all the accounts. So you can always return to your environment and exercise if you remember which email account you used. Once you're accessing an environment in console, look in the console what it says for your user information. So if you have your company account, you have your school account, make sure that you are not in the context of your school account or your company account, because then you would be spending resources and money in those accounts. So be very sure that you actually are looking at the exercise account. It will have all the stages mentioned here. It will talk about a lot about how to access it, how to use command line interface, and then it will go through all the clue niceties and things. So that is pretty much it. I know that we are getting on top of the hour, so let me see if there's anything anybody wants to ask. So we can do a bit of Q&A. So Sanna, do you see that we have a lot of questions?
Yes, we have. I can read these.
Yep.
If we want to showcase the projects we built for data engineering, is there possibilities to push them to GitHub from AWS after we have completed them?
Yeah, so I see that there's a lot of people who are using GitHub. So yes, you can do so. Some people use different programmatic ways. Of course, if it would be like the Glue transformations, you could just take the Python and such code. I know that some people even take the whole stack that you have created and turn it into like a CloudFormation stack or similar and publish that. So kind of to showcase that this is what I've built. So there are ways to do that. So I can maybe share, if I could, I can share a couple of examples of like, we have a community called AWS Ambassadors, and they do use a lot of GitHub. So maybe I can share a couple of people's GitHubs to kind of showcase that that's what they're using. So that might be useful. So I can let me actually take a note of that. So I will remember to do that. And so that's one way. Anything else?
Yes. Does data lake follows the ELT primarily or ETL? I understood that the cost for ELT might be cheaper as transformation is done as per requirements and data lake stores the data as it is.
So that has actually, that could be answered in many ways. So one thing is, of course, how the company gets their data. So very typically what you see is that they get the raw data. Let's say it's like, let's say IoT data. And then it means that then you might need to do the transformational side. But I also see a lot of companies using the raw data for calculations, like base their calculations, because it's typically more accurate that way. So it really depends on the use case. So you might have the fact that you do need to transform it, and then you're paying for the transformation, but you pay only for what you consume. So the kind of the calculation side, or then you might able to access just the raw data and skip the whole transformation if you know that your calculation will have more accuracy that way. So I kind of have like it's a twofold answer. So it depends on the use case.
All right. Is QuickSight is something similar to MS Power BI?
Yeah, so you could compare it, yeah, pretty much. So you could say like it's a reporting service, it's a serverless reporting service, and it combines, and I think I don't know like Microsoft side that well, but I would say they probably have similar things that it combines with machine learning now, and you might have like chat assistants and things. So very, very similar, and primary purpose is the visualization and reporting and providing different reports to end users. So very similar.
Yes. We are talking about different visualization techniques based on the data type and analysis needs. Is this the right job descriptions for data engineers to actually work on the analysis part? Or or as data engineers, we need to connect the related microservices for analysis to the data lake in order for people to access and analyze the data.
So I would say that also depends a bit on the size of the organization. So what I'm seeing a lot is that you might have really large organizations that has lots like data engineering teams that will fundamentally like transform, create the base stack on how to access the data. And then you might have like data analyst teams that will do a whole lot with the visualization side, or let's say that you do a lot of like science-based calculations. So then there's like data scientist type of roles. But then again, if you turn it the other way around, you might have really lean organizations that the data engineering team does all and everything. So they have the prepping and cataloging and user rights, and then they will even do like a lot of data science. And it's also a lot about preference. So for example, my background, even though I haven't been like a data scientist as such, has still included a lot of calculations because of my kind of my school background and my personal interest. So it's usually negotiable with the company of, you can say like my preference would be to take part in this too. So you can adjust it.
Okay. Would you provide some practical articles on learning data practicing, or would we exercise would include a step like this?
I can share a bit more on that. So I can actually share a couple of links. Some of them are like prescriptive guidance from our side. And then I can share a bit more on kind of, I can see if I even have a deck that I could give you that you can kind of read through. So it's definitely an interesting topic. You have all the access in the accounts that you can actually practice that already in the accounts that you have right now. I think we are on top of the hour, so I have one request for you. So, hey, thank you everybody for your time. We will see in the next one. I have Veli-Matti Ovellu who's joining us to talk about also data modeling next time. If you are in a career transformation phase, and if you would like to kind of investigate the benefits of kind of programs that we are doing and also Mimmit Koodaa programs, there's one request that we would like to extend to you, and is that if you would like to kind of share your experiences and what is the benefit of having training programs, could you ping Sanna in, for example, in the Slack, or send an email if Sanna, you can share an email address that can be used. We would kind of like to pick your brain of how it's functioning. Is it functioning? Is there something that we could do better? So that is more like a free form request of any data is always useful. So that is pretty much it. So, hey, thank you everybody for your time. Have a great week. You will have access until I think Thursday. So now we are Thursday, so Sunday midday to access the environments. Thank you so much and see you soon again.